Top 30 Senior Java Developer Interview Questions and Answers. Preparing for a Senior Java Developer interview requires more than knowing Java syntax. Employers usually evaluate your understanding of advanced Java concepts, object-oriented programming, collections, multi-threading, concurrency, Spring Boot, microservices, databases, system design, performance optimization, testing, and software architecture. This guide provides 30 important Senior Java Developer interview questions with practical, professional answers. Each answer is designed to help you communicate your technical knowledge clearly while demonstrating senior-level problem-solving, design thinking, leadership, and real-world development experience during your next Java interview. What is the difference between JDK, JRE, and JVM?
The JDK, or Java Development Kit, provides tools required to develop Java applications, including the compiler, debugger, and JRE. The JRE, or Java Runtime Environment, provides libraries and components needed to run Java applications. The JVM, or Java Virtual Machine, executes Java bytecode and provides platform independence. In modern Java distributions, developers typically install the JDK because it includes the runtime environment and development tools needed for building and executing applications.
What are the main principles of object-oriented programming in Java?
The four major object-oriented programming principles are encapsulation, inheritance, polymorphism, and abstraction. Encapsulation protects object data by controlling access through methods. Inheritance allows classes to reuse behavior from parent classes. Polymorphism enables the same interface or method to behave differently depending on the implementation. Abstraction hides unnecessary implementation details and exposes essential functionality. As a senior developer, I apply these principles carefully to create maintainable, loosely coupled, testable, and extensible software.
What is the difference between == and equals in Java?
The == operator compares primitive values directly, but when used with objects, it compares references to determine whether two variables point to the same object. The equals method is intended to compare logical object equality based on class-specific implementation. For example, two string objects may contain identical text while having different references. As a senior developer, I use equals for value comparison and ensure hashcode is implemented consistently whenever equals is overridden.
Explain the difference between hashmap and concurrent hashmap.
Hashmap is not thread-safe and can cause inconsistent results when multiple threads modify it concurrently. Concurrent hashmap is designed for concurrent access and provides better thread safety without locking the entire map for most operations. It allows multiple threads to read and update different portions efficiently. I choose concurrent hashmap when shared mutable map data must be accessed by multiple threads. For single-threaded applications, hashmap generally provides simpler and efficient behavior.
What is the Java Stream API?
The Stream API provides a functional approach for processing collections and other data sources. It supports operations such as filter, map, sorted, distinct, reduce, and collect. Streams can improve readability by expressing what should happen rather than focusing on implementation details. They can also support parallel processing when appropriate. However, I avoid unnecessary parallel streams because they may introduce overhead and concurrency issues. I select streams when they make transformations clear, concise, and maintainable.
What is the difference between checked and unchecked exceptions?
Checked exceptions are verified by the compiler and must either be handled or declared using throws. Examples include I/O exception and SQL exception. Unchecked exceptions extend runtime exception and generally represent programming errors or invalid states, such as null pointer exception or illegal argument exception. I use checked exceptions when callers can reasonably recover from an external failure, while unchecked exceptions are appropriate for programming or validation problems. Good exception handling should preserve meaningful context without hiding important failures.
How does garbage collection work in Java?
Java garbage collection automatically identifies objects that are no longer reachable and releases their memory. Modern JVMs use generational strategies because most objects have relatively short lifetimes. Garbage collectors such as G1, ZGC, and others use different approaches to balance throughput, memory usage, and pause times. As a senior developer, I monitor heap usage, allocation rates, garbage collection pauses, and application behavior before tuning JVM settings rather than changing parameters without evidence.
What is multithreading, and how do you handle concurrency in Java?
Multithreading allows multiple execution paths to operate concurrently within an application. Java provides thread, executor service, completable future, synchronized blocks, locks, atomic classes, and concurrent collections for managing concurrency. I prefer higher-level abstractions such as executor service and completable future rather than manually managing threads. I also minimize shared mutable state, use immutable objects where possible, and carefully identify synchronization requirements. Proper concurrency design improves responsiveness while reducing race conditions, deadlocks, and difficult-to-reproduce production failures.
What is the difference between synchronized and lock?
The synchronized keyword provides straightforward intrinsic locking managed automatically by the JVM. The lock interface, including reentrant lock, provides more advanced capabilities such as timed lock acquisition, interruptible locking, and explicit lock management. I prefer synchronized when simple mutual exclusion is sufficient because it is easier to read and less error-prone. I use lock when the application requires advanced synchronization behavior. Regardless of the approach, I ensure locks are released reliably and avoid unnecessarily large critical sections.
What is dependency injection in Spring Boot?
Dependency injection is a design technique where required dependencies are provided to a class rather than created directly inside it. Spring manages these dependencies through its application context and automatically supplies appropriate beans. I generally prefer constructor injection because dependencies become explicit, objects can be immutable, and testing becomes easier. Dependency injection reduces tight coupling, improves maintainability, and allows implementations to be replaced without modifying business logic. It is fundamental to designing testable Spring Boot applications.
What is Spring Boot, and why is it widely used?
Spring Boot simplifies development of production-ready Java applications by providing auto-configuration, starter dependencies, embedded servers, externalized configuration, and operational features. Developers can create applications with significantly less boilerplate configuration compared with traditional Spring projects. Spring Boot is widely used for REST APIs, microservices, enterprise applications, and cloud-native systems. As a senior developer, I use its conventions while still reviewing generated configuration carefully to ensure security, performance, observability, and maintainability requirements are properly addressed.
What is the difference between at component, at service, and at repository?
At component is a general-purpose Spring stereotype used to register a class as a bean. At service is a specialized stereotype commonly used for business logic classes, while at repository identifies persistence-related components and can enable exception translation for database operations. Functionally, all are Spring-managed components, but their semantic purposes improve code organization and readability. I use the most specific annotation appropriate for each class, because clear architectural boundaries make large applications easier to understand, test, and maintain.
How would you design a REST-TFL API using Spring Boot?
I would begin by defining resources, HTTP methods, status codes, request validation, authentication, authorization, and error responses. Controllers should remain thin, delegating business logic to service layers. DTOs should separate external API contracts from persistence entities. I would implement centralized exception handling, logging, metrics, documentation, and appropriate pagination. For production systems, I would also consider idempotency, versioning, rate limiting, caching, database performance, security, observability, and backward compatibility before finalizing the API design.
What are microservices, and when would you use them?
Microservices divide an application into independently deployable services organized around business capabilities. Each service can potentially have its own technology, database, scaling strategy, and release cycle. I would choose microservices when organizational scale, independent deployment, domain boundaries, or varying scalability requirements justify the additional complexity. I would not automatically convert a monolith into microservices because distributed systems introduce network failures, operational overhead, monitoring challenges, data consistency concerns, and more complicated testing and deployment requirements.
How do you improve the performance of a Java application?
I begin by measuring performance rather than assuming where the problem exists. I examine application metrics, logs, CPU usage, memory consumption, garbage collection, database queries, thread behavior, and response times. Profilers and monitoring tools help identify bottlenecks. Improvements may involve better algorithms, optimized queries, caching, connection pooling, asynchronous processing, reduced object allocation, or appropriate JVM tuning. I always benchmark significant changes and confirm that optimization improves the actual business requirement without unnecessarily complicating the code.
What is the difference between an interface and an abstract class?
An interface primarily defines a contract that different classes can implement, while an abstract class provides a common base that can contain state, constructors, concrete methods, and abstract methods. A Java class can implement multiple interfaces but can extend only one class. I use interfaces when different implementations should follow the same contract, and abstract classes when closely related classes genuinely share implementation or state. Choosing between them depends on the desired abstraction, coupling, reuse, and extensibility.
What is immutability, and why is it important?
An immutable object cannot be changed after it is created. Immutability improves thread safety because objects can be shared without synchronization when their state never changes. It also simplifies reasoning, caching, testing, and debugging. String is a common Java example. When designing immutable classes, I typically make fields final, avoid setters, initialize all state through constructors, and protect mutable references through defensive copying. Immutability is particularly valuable in concurrent applications and distributed systems, where shared state increases complexity.
What is completable future used for?
Completable future supports asynchronous and non-blocking programming by allowing tasks to run independently and results to be composed through methods such as then apply, then compose, then combine exceptionally and handle. It is useful when applications need to execute independent operations concurrently or coordinate asynchronous workflows. I carefully manage executor configuration rather than relying blindly on defaults. I also handle timeouts, failures, cancellation, and thread pool capacity, because asynchronous code can otherwise create resource exhaustion or difficult operational problems.
How do you prevent deadlocks in Java?
A deadlock occurs when threads wait indefinitely for locks held by one another. I reduce deadlock risk by maintaining consistent lock ordering, minimizing nested locks, keeping critical sections small, avoiding unnecessary synchronization, and using higher-level concurrency utilities where appropriate. When explicit locks are necessary, timed acquisition can provide an escape mechanism. During troubleshooting, thread dumps and monitoring tools help identify blocked threads and lock ownership. Good concurrency design prevents most deadlocks before production deployment.
What design patterns have you used in Java projects?
I have used patterns such as factory, strategy, builder, singleton where appropriate, adapter, observer, template method, and repository. For example, strategy can separate multiple business algorithms, factory can centralize object creation, and builder can simplify construction of complex objects. I do not apply patterns simply because they exist. I first understand the problem, then choose the simplest design that improves flexibility, readability, and maintainability. Overusing patterns can introduce unnecessary abstraction and make systems harder to understand.
How do you handle database transactions in Spring?
In Spring applications, I commonly use @transactional to define transaction boundaries around business operations. A transaction should generally encompass a logical unit of work that must succeed or fail consistently. I consider propagation, isolation, rollback behavior, transaction duration, and database constraints carefully. I avoid holding transactions open during slow external calls because that can consume database connections unnecessarily. I also verify transaction behavior through integration testing, rather than assuming annotations automatically solve every consistency problem.
What is the difference between SQL joins?
SQL joins combine rows from related tables based on specified conditions. An inner join returns matching records from both tables. A left join returns all records from the left table and matching records from the right. A right join does the reverse, while a full outer join returns records from both sides where supported. As a senior developer, I choose joins based on business requirements and examine query execution plans to ensure relationships are indexed and queries remain performant.
How do you secure a Spring Boot application?
I approach security through authentication, authorization, secure communication, input validation, dependency management, and appropriate data protection. Spring Security can implement authentication and authorization rules, while HTTPS protects network communication. I validate user input, avoid exposing sensitive information in logs, securely manage secrets, and apply least privilege access. I also monitor dependencies for known vulnerabilities and keep security configurations current. Security should be designed into the application architecture rather than treated as an afterthought.
How do you test a Java application?
I use multiple testing levels, including unit, integration, API, and end-to-end tests where appropriate. Unit tests verify focused business logic quickly, while integration tests validate interactions with databases, messaging systems, or frameworks. Mockito can help isolate dependencies during unit testing. I aim for meaningful coverage rather than chasing a percentage alone. Tests should verify important behavior, edge cases, failures, and business rules. A strong automated test suite provides confidence during refactoring and frequent deployments.
How do you approach code reviews as a senior Java developer?
I focus code reviews on correctness, maintainability, security, performance, testing, architecture, and consistency rather than personal preferences. I first understand the purpose of the change and then examine whether the implementation meets requirements. I look for unnecessary complexity, potential bugs, missing tests, concurrency issues, and problematic database operations. Feedback should be specific and respectful, explaining the reasoning behind recommendations. As a senior developer, I also use reviews as opportunities to mentor teammates and improve shared engineering practices.
How would you troubleshoot a production performance issue?
I would first determine the scope, impact, and symptoms using monitoring dashboards, logs, metrics, and traces. I would check CPU, memory, garbage collection, thread pools, database latency, external dependencies, and recent deployments. Distributed tracing can help identify where request time is being spent. I would avoid making random configuration changes and instead reproduce or isolate the bottleneck when possible. After implementing a targeted fix, I would monitor the system closely and document the root cause.
What is caching, and when should it be used?
Caching stores frequently accessed data closer to the application or user so repeated requests can be served faster. It can reduce database load and improve response times significantly. However, caching introduces concerns around expiration, invalidation, consistency, memory usage, and stale data. I use caching when data is expensive to retrieve and can tolerate the chosen consistency model. I define clear cache keys, expiration policies, and fallback behavior, and I monitor cache hit rates to confirm the strategy actually provides value.
How do you design scalable Java applications?
I begin with clear domain boundaries, efficient algorithms, stateless services where practical, and appropriate database design. Horizontal scaling can be supported by keeping application instances independent and storing shared state in suitable external systems. I also consider caching, asynchronous processing, connection pools, message queues, load balancing, and observability. Scalability should be validated through realistic load testing. As a senior developer, I balance scalability with simplicity because premature distribution or optimization can increase operational complexity without solving an actual business requirement.
How do you handle disagreements about technical decisions?
I focus discussions on requirements, measurable evidence, risks, and long-term maintainability rather than personal opinions. I encourage team members to explain their reasoning and compare alternatives objectively. When useful, I suggest prototypes, benchmarks, architecture diagrams, or proof-of-concept implementations to validate assumptions. If the team reaches a decision, I support it professionally even when my preferred option was not selected. Senior developers should create an environment where constructive disagreement improves technical decisions rather than damaging collaboration.
Why should we hire you as a senior Java developer?
You should hire me because I combine strong Java expertise with practical software engineering and problem-solving skills. I can design maintainable applications, troubleshoot complex production issues, improve performance, review code, and work effectively with databases, Spring Boot, APIs, and distributed systems. I also understand that senior development involves communication, mentoring, ownership, and sound technical judgment. My goal is not simply to write code, but to deliver reliable solutions that support business requirements and long-term product growth. A successful senior Java developer interview requires a strong combination of technical knowledge, practical experience, architectural thinking, and communication skills. Reviewing these 30 questions can help you prepare for discussions involving Java fundamentals, Spring Boot, concurrency, databases, microservices, security, testing, performance, and leadership. During the interview, focus on explaining your reasoning and supporting answers with real project examples whenever possible. Confidence comes from understanding concepts deeply, not memorizing responses. Use this guide as a foundation, practice speaking your answers naturally, and prepare to explain the decisions behind your technical solutions.